In today's lesson, we are going to be looking at proportions. With these proportions, you're going to be looking at how we can use proportions in separate setups and multiple ways of setting them up to represent the same situation. And we'll also be solving with cross products. So what we're going to start with is this explore activity. It says 5 players on a television reality show are stranded on an island as part of the competition. The group is given 50 cups of rice with a 1-cup scoop plus bottled water for nourishment, and they are dependent on their surroundings for shelter. Since the rice is so important to their survival, they need to figure out how to divide the rations fairly. Evan suggests dividing the rice equally by giving 10 cups to each person. Alan says this is unfair because he weighs more than the other contestants, yet his portion of the food is the same. Becca agrees with Alan, suggesting that they find a more fair way to split the rice. They discuss ideas as a group and agree that everyone should get at least 1 cup. Well, let's hope so. They've got 50. They decide that rice should be given in proportion to weight. So they do end up agreeing that it should be in proportion to weight and not that it should just be given equally among them as 10 cups. They get rid of that idea. Since they have no other measuring tools besides the scoop, they decide that only whole cups of rice will be distributed. Below are the 5 players and their weights. For part A, it says to find the distribution of rice that is consistent with the players' agreement. So we know that we have a total of 50 cups of rice. And we're going to be splitting them as evenly as possible between the different contestants. So what I want to do is I want to think of each contestant's weight compared to the overall total of the group. So in order to compare it to the overall total of the group, I want to add up all of the weights. So if I add up the weight of all of the players, I end up with 880 pounds. So if we wanted to find out how much rice Alan will get, we want to find out what percent of his weight or what proportion of his weight he is compared to the rest of the group. So I'm going to have 297 divided by the 880 pounds. And so we get 0.3375. So that's how much of the whole amount Alan's weight is compared to the total. If I know that that is the proportion, I can take that times the number of cups of rice that I have, which is 50, to get 16.8 cups of rice. Now it says that we're going to use only whole cups of rice because they only have that 1 whole scoop to use. So that would be 17 cups. Okay, let's go ahead and find out what Chris's would be. So I'm not going to have us do all of them, just some of them. So for Chris, he is 161 pounds, and the group has a total of 880 pounds. So we get 0.1829. We're also going to take that times 50. That's the overall cups of rice for the group. And we get 9.14, which is closer to 9 cups. All right, and let's also look at Evan. So Evan weighs 105 pounds. We're going to take that out of 880, and we get 0.119. I'm going to multiply that by 50, and I get 5.96 cups, which will round to 6 cups. So it's no wonder that Evan wanted us to go with splitting it evenly. We're going to not worry about the second part of that question. So, while guess and check could have been used in the explore problem to figure out who would have gotten how much, that might have been tedious. So what we did is we looked at proportionality, and that provided a more direct way of finding a fair distribution of the rice. This section is going to explore problems that involve proportional relationships and use algebraic methods to solve them. One method in statistics for finding a sample from a larger population is to divide the population into distinct groups called strata. A sample can be formed by choosing proportionally from each stratum, which is just the singular version of strata. This is known as stratified sampling. So for example 1, it says suppose a stratified sample of 250 students is needed from a population of students with various degrees as shown in the table. How many students should be chosen from each degree type if the number of students with a particular degree in the sample is to be proportional to the number of students who hold a degree in that population? So with this one, we want to think about how to keep it proportional. So I know that the total number of students that I'm going to have for my sample is going to be 250. I also need to figure out what my total would be for my set of students in this population. So if I go ahead and add up all of these values, I get 2,555. So this is going to be an important value to use when we're setting up our sample. So what I'm going to do is I'm going to find out for the AA major, which is probably the Associate of Arts, what proportion of the population is that major. So I'm going to take 1,575 out of the total, 2,555. And I get 0.6164. And I'm going to take that times the total number in our sample, which is 250. And I get 154.1, which is 154 students. Okay, I'm going to do that same idea. I'm going to next do AS, which is probably the Associates of Science. So I'm going to take 565 out of the 2,555. Now we would expect this one to be a smaller sample because it's much less than the first one. So for this one, we get 0.221, and I'm going to take that times 250. And I get 55.2, and that would be closest to 55 students. Okay, for the last one, I'm going to have us do that one just a little bit differently so that you guys can see how we can set it up also as a proportion. So for the AAS one, I'm going to take and have 415 out of the 2,555. So this still represents the division that I was doing in these other ones. But what I'm also going to do is when I look at this, this is for the overall population. And this one is for the sample. We know that in the sample, there will be a total of 250 students. I want to know how many of them will be coming from this section. So X is going to be my variable. So to solve this, you guys are going to cross multiply. So you're going to take 415 times 250, and that will end up equaling 2,555x. If you multiply those together, you get 103,750. So to solve this, I'm going to divide both sides by 255, and I end up with 40.6, which will round to 41 students. And so we have altogether our 250 students. So we can refine how we solve proportions when the ratios are not scaled up or down, such as in this next example. When we look at this one, notice that this proportion is true. 2/3 equals 8/12, because you can think, what would I do to 2 to get 8? And if you multiplied by 4, you would get 8. And if you do the same to the bottom, you would get 12. So this one was just scaled up by 4. So in the equation, 2 and 12 are diagonal, which we call our cross products, and we can also see that they end up equaling each other. So if you were to take 2 times 12, it's equal to 3 times 8. Both will give you 24. So we're able to solve it that way as well. In proportions, cross products are equal. So we can use this idea to solve it. So we could have 17x equals 12 times 8 and solve from there. So that's what we're going to do when we have our proportions. These ones are a little bit trickier, but I want us to make sure that we know how to solve these. If you have part of your proportion where it has more than one term, you want to make sure that when you multiply, you put parentheses around it. So for this one, it would be -3 times the quantity x minus 1. And then your other side is going to be 5 times the quantity x plus 1. So let's go ahead and solve both sides. So for the left, we get -3x plus 3. For the right, we get 5x plus 5. So make sure that you're distributing correctly. Okay, I'm going to move the smaller one. So I get 3 equals 8x plus 5. I'm going to subtract 5 from both sides. I get -2 equals 8x. Divide by 8. And I get -0.25, or -1/4. For this one, I'm going to cross multiply, but I'm going to make sure that 4x plus 7 is in parentheses. And then I'm going to have equals 5 times x. So I'm going to distribute. So I have 12x plus 21 equals 5x. For this one, I only have an exponent over here, so I'm going to subtract this one. So I have 21 equals -7x. Divide both sides by -7, and I get -3. So biggest thing here, if you have more than one term in part of your proportion, you're going to make sure to put parentheses around it and then distribute when you multiply. Okay, so as a step for solving these, you're going to form a ratio by comparing two values. Include the units in the ratio. This will make sure that you set it up properly. Form another ratio by using the other values and one additional fact. Write the ratio with quantities in the same relative position as the first ratio. All right, so this is where you want to make sure that the units help you. Set the two ratios equal to each other. and solve. State your answer with the correct label. Okay, so looking at example 2, it says a paper company has been reducing the size of its paper towel rolls in an effort to address rising costs. By keeping the price at the same level but dividing less of the product, the company can recoup the increasing costs to manufacture paper towels without customers paying more per roll. Actually, with this one, I'm going to have us skip this one. Sorry, I left it out of the notes last year and I forgot to leave it out this year. Okay, so we're going to look at example 3. Ben and his roommates order pizza and Chinese takeout for dinner. Ben tips the driver $5 for a $21 pizza. All right, so we've got $5 tip for a $21 pizza. How much should he tip the driver who delivers the Chinese food that costs $34 so that he tips each driver the same percent, or you can even think the same proportion? Okay, so what I'm going to have us do here is I'm going to have us look at the fact that we've got our pizza and our Chinese food. So with our pizza, we have two things. We've got the tip amount, and then we also have the overall cost. So for the pizza, the tip amount was $5, and for the overall cost, it was $21. I want to set this up to the proportion for Chinese food. For Chinese food, I do know the overall cost, and that's $34. It's the overall cost, so it's going to go on the bottom. So it's important that you put it on the bottom. What we're solving for is the tip amount. Okay, so this is my proportion. I'm going to now solve it by cross multiplying. So I'm going to have 5 times 34 equals 21x. So 5 times 34 is 170, and that's equal to 21x. So you're going to divide both sides by 21, and you get 8.09. And it's said to round to the nearest dollar amount, so we would have $8 for the tip for the Chinese food. Now, if you set this up a little bit differently, let's say that you have your Chinese food and your pizza switched. So maybe you have x over 34 equals 5 over 21. That's okay. That still works because you end up multiplying 21 in x and 5 in 34. Maybe you switched what went on the top and what went on the bottom. Maybe you have for pizza and Chinese food, but now you have the cost on the top and the tip amount on the bottom. That's okay as well, because look in this one. This one, you're still multiplying 21 in x, 5 and 34. And maybe you switched both. You switched which side it goes on and which one goes on top. So maybe you have 34 over x equals 21 over 5. This one is still fine because you're still multiplying 21 in x and 34 times 5. So as long as you keep the same position, you're fine. Okay, looking at example 4. It says apportioning whole number quantities according to certain ground rules has long been a part of determining seats in the U.S. House of Representatives. The Constitution states that the number of representatives will be determined based on each state's respective number, meaning its population. Each state must get at least 1 seat. Currently, there can be no more than 435 seats total. According to the 2010 census, the population of the United States was 309,183,463 people. So we're going to use proportionality to find the number of seats the U.S. House of Representatives has for each of the states in the table. And then you're going to round to the nearest number. We're only going to do this for one of the states. So let's go ahead and do it for Ohio. So we're going to think of our state population over our total population. And we're going to still have our state over our total, but now we're going to think of the number of seats. So this would be an appropriate way to set it up for any of the states. So if I'm doing this for Ohio, I'm going to have 11,568,495 over the total for the United States, which was 309,183,463. We don't know how many seats Ohio will get, but we do know that there are 435 total. So you're going to cross multiply. So when you multiply 435 and 11 million blah blah blah, we get 5,032,295,325, and it is equal to 309,183,463x. So we would divide by this. So here's a quick way of thinking it. You multiply these two together and then divide by that number. And we get 16.27, which is closest to 16 seats. Okay. So I'm going to also have us look at a few other examples on the next sheet where it has the review. So go ahead and jump to our proportion ones, which will be a little bit further. Okay, so starting on number 18, we have ones that you would solve the actual proportions. That would just be solving these. So like for 18, you would have 4 times x equals 6 times 8. So 4x equals 48. And then divide both sides by 4. You would get 12. Make sure that you're careful on ones like 19, because you're going to use parentheses around the 4x plus 7. But let's go ahead and do a few practice ones starting on that next page where you have number 21. This one says the ratio of the weight of an object on planet A to the weight of the same object on planet B is 200 to 9. So it gives us a ratio of planet A to planet B being 200 to 9. It says an elephant weighs 15,000 pounds on planet A. Find the elephant's weight on planet B. So what I'm going to do is I'm going to think first of, I have my overall ratio. I have what it is for planet A as 200 and for planet B as 9. I also know that on planet A, The elephant weighs 15,000 pounds. I don't know what it is on planet B. So that is my unknown. So for that one, I'm going to have X. So to solve it, I'm going to cross multiply. So we have 200x equals 9 times 15,000. So 9 times 15,000 is 135,000. Okay, the next thing I'm going to do is divide both sides by 200. And I end up with 675, and make sure that we include a label. Pounds. And so the elephant would weigh 675 pounds on planet B. Okay, let's just do a few more. For number 22, it says a restaurant uses 2 pints of milk with 3 pints of cream to make their coffee creamier. So we have a ratio. We've got 2 pints of milk for every 3 pints of cream. It says to make a larger quantity, how many pints of cream should be used for 18 pints of milk? So for this one, we have 18 of milk, and we want to know how many we'll have of cream. So I'm going to cross multiply. So that's going to be 2x equals 3 times 18. Okay, 3 times 18 is 54. So divide both sides by 2, and I get 27 cups of cream. Number 23. Jim drove 276 miles in 6 hours. If he can keep the same pace, how long will it take him to drive 1,242 miles? So if I look at this is 276 miles in 6 hours. In the second scenario, I'm also given an amount of miles, so that will go on the top. I don't know how many hours it will be, so that will be X. So when I cross multiply, I'm going to have 276x equals, and then those will multiply together to give me 7,452. So divide both sides by 276. And I get 27 hours. The last one that we're going to do, it says if there are 50 cups of rice for a group of 5 people who have a combined weight of 900 pounds, this should sound similar to that first problem we did together. Determine how many cups of rice a person who weighs 183 pounds should receive. Okay, so we have for the overall group, we have how much rice they should get, and we have how much weight overall the group is. Then we have the one person. We know the one person is 183 pounds. I want to find out how much rice they should get. So you're going to cross multiply. So multiply 50 and 183. You get 9,150. And it's going to be equal to 900x. So to solve, divide by 900. we get 10.167. So this would round to 10 cups of rice. Okay, this should get you set on all of your section 14 notes. Just let me know if you guys have any questions.